Welcome. So, in this session, we're going to start working on the last part of the course. The last part of the section on Python fundamentals, Python basics. So, we've covered a lot of the important stuff as regards Python for data science and analytics. But then, object-oriented programming, we need to look at another important concept that is, very important um, to Python for data science. It is not as important, in my opinion, it is not as important when it comes to Python for data analysis, but it is still like, good that you understand it. Even though you're not going to be doing a lot of it, you're not going to be using it as much in Python for data analysis, really. So, but it is extremely, extremely important in Python for data science. So, and this concept is object-oriented programming. So it's not something that is limited to Python alone. Across different programming languages, you have OOP. A handful of programming languages support it. And so what's OOP? So OOP is a programming paradigm actually, and the easiest way to think about it is from the angle of why does it exist? Why does OOP exist? So OOP exists because think about this scenario, right? So in real life, we think in terms of objects, like generally in real life, like everything that exists is an object. A laptop is an object, a car is an object, you might even really want to look at it and be like, okay, a person is an object also, like it's a thing, an entity, even though it's a living thing. Now, let's say a dog now. So the object dog is going to be um the composition of two things really. And the two things are, number one, what the dog can do, that is the functionality, and the other side is going to be the characteristics of the dog, like the features of the dog. So, and something like a car also is going to be the functionalities of a car, what the car can do, and the other thing is going to be the features of the car, like the things that you can use to describe the car. And if you look across, several different objects, if you keep thinking, laptop and all of that and all of those stuff, you're going to see that it is just mainly really what the object can do, the functionality, like when you press the power button on the laptop, causes the laptop to turn on. That's a function, that's a functionality. Then there is the attributes. Okay, it's a MacBook, it is a black MacBook, it is uh, it has this size of RAM, it has this date as the manufacturing date, and things like that. So that brings me to every single object, even in programming, also has two things. Number one is the functionalities, the things that causes the um, object to do something, to act in a way, and also the things to describe the data or the state in that particular object. So, and this is also entirely what the concept of OOP is about. Everything in Python, for example, is an object, right? And Python, as you know, the good people at Python, they've created all of those things, and we can also create our own, just the same way where there are built-in functions and we are allowed to create our own functions. Exactly, everything in Python is an object. We are also allowed to create our own object, and that's the entirety of what OOP is about. Now, how do we now create object? To create object, what we do is actually we define the class of the object. And what's the class? The class is like the blueprint. So let's say we want to create an object person. So I can go class. Let's actually add a so, O object oriented programming. Let's say OOP. OOP. Python. Now, if we want to define a class, which I said earlier that it is the blueprint of an object. That is, whenever you want to create an object, it's just like whenever you want to build a house, you start with the architecture, right? So the class is also the blueprint, the architecture of an object. So that whenever you want to create your own object, you expect that object to follow that blueprint. So once it follows that blueprint, it is going to behave exactly the way any instance of that particular um, object is going to behave exactly like we've defined it in the class. So this is what I mean. I mean, if we do class person, and it is common practice that we begin class name with capital letter, and I just say pass for now, like there is nothing in there. Now, if I should run that and go to the next line, it's still connecting, still connecting, still connecting. And if I should say, um, what's bro? Okay, it's done. So if I should come here and say we want to create an instance of this particular object. We've created this class here, this blueprint. There is nothing in it, it's just void, like nothing inside it. So we come here and say John is a person, and we say John equals person, like this. Now, if I should say print type John, it's going to say class of what person. And you must have seen something that looks like this before. Because if I should come here and say um number, so let's say age equals 55, and I come here and I print type age, and I run this, you're going to get class integer. It says class of integer, meaning this particular 55 is expected to behave, this particular age variable, which is 55, is expected to behave exactly the way every single integer in Python behaves. So the same thing happens here also, that we are having this here and we are saying this John here is expected to behave exactly the way every single person object is expected to behave. So we call this John here, we call it an instance of the class person. The same way age is an instance of the object of the class integer. I hope that makes sense. So that is that. So a class defines the blueprint. It doesn't represent any specific person really. It is not tied to a single person. It just represents the type, like the data type. So you can think of this thing as data type, and it is the blueprint. Okay, this is how all of these things should be. So, for example, if you look at a mansion and a duplex and all of these things, we can have two houses that are mansions, and the reason why they are mansions is because they follow the blueprint of what a mansion should look like, which is not something that you find in, let's say, a bungalow. So that is the exact thing that is happening here. So whenever we want to create an object, all we have to do is just define the blueprint using this class. Now, let's actually now and what we did here is we created an instance of a person object. So create an instance of a person object. Now, if we come to this is just for comparison sake, so I'm going to remove this. Now, the next thing that we're going to do is we are actually going to add state, because currently, and moving forward in this course, I'm going to only like be editing this particular um object here, this class. So the next thing we want to do is, well, this thing does not have anything, like it does not have data, does not have sales, does not have functionality, anything. So we're going to give it some functionality. We're going to give it some data. Let's start with giving it the data. I want to give it life. We want to give it features. So, and the first thing we want to add is something called constructor. And what's constructor? Constructors allow us, they help us to actually add data to our object. For example, we cannot add name. For example, this is person one and John. So let me actually call it person one like this. So I should come and say person one and run this. It still works. But then, we should be able to add the name of this person, their age, and things like that. So how can we do that? We can do that by adding the constructor. So the constructor is the part where we add attributes to our object. So how do we do that? We do that by, let me see, add constructor. We do that by using the init method, and you're going to see it. How do we do it? You're going to say def double underscore. This is double underscore. Some people will say dunder init. And in the bracket here, every time you must start off by writing self. And I'm going to explain what that means in a bit. Then the attributes that you want to pass in, the features, So we're going to say name. A person should have a name. A person should have a birth year, and a person should have a, what else should they have? They should have a state. They should have a state of origin, or let's say birthplace or nationality. Good. Now, just exactly like you're defining a function, but then you must have done that in it. But don't worry about this self for now. Let's finish it. So the next thing we want to do is, I think this might be the perfect time to explain self. Now, what does this self do? This self refers to this, like the current object that we are currently running. For example, I can have person one, then have another one, person two. That one is also going to be equals to person, because don't forget, we said this main person here is just the blueprint that we've defined here. Is that right? So now let's say two people wants to build a mansion, and well, they want the exact kind of mansion, the exact same mansion. We can draw out our blueprint, make a copy of it, give it to person one, give it to person two. But at the end of the day, these are two separate blueprints, although they are the same in terms of everything that is there, the composition, the everything. But it is two separate houses that we want to build. So we give the first one to person one, give the second one to person two. We need to like have a way to refer to, okay, this is your own and that is your own. And this is what self is. So this self gives us the opportunity to always refer to the current instance that we are running, which is person one. So whenever we are calling person one, self becomes person one. Whenever we are referring to person two, self becomes person two. And that is what happens. So how do we use that? We are going to say, if I should come here, I'm going to say self dot name equals to, so the name that we pass in this variable here, this name here, we're going to say self dot name, because that's so that person, whenever we are creating the object for person one, that's going to be person one dot name equals name, then self dot bat here, that's going to be bat here, so that whenever we are looking at person one dot bat here, that's going to be the bat here that we supplied at the point of creation. If it's person two, it's going to be the one that we created for person two. So I'm going to say self dot nationality, and that's going to be equals to nationality. Perfect. And if that's everything we do, we run this. Let me just make this go up a bit. Perfect. So let's run this. Now, if we want to run this again, it's going to throw an error, because if I run this, we're going to get an error that says, don't forget, this is the blueprint, right? So it's going to tell you, well, you are trying to create this instance of this, and you're not following this blueprint, because this blueprint it says person dot init missing three required positional arguments: name, birth year, and nationality. Anybody that must use person, that must create an instance of person, must always pass in name, birth year, nationality. That's what they are saying. So I'm going to say name equals John, birth year equals 2001. Nationality equals Nigerian. Then here we can have name equals Ruth. Birth year equals 1990, 1990. And nationality equals American. Now, if I should run this, now it has created our instance of person object. We created two instances. So we have person one and we have person two, two different instances. So I can go on here and say person one dot name, and it's going to print out what's the name, John. And on the next line, if I should do person two, sorry, excuse me, person two dot name and run that, it says Ruth. And the way, just to circle back a little bit to this self, the way it knows to not confuse person one's name with person two's name is because of this self keyword here. So the moment we run person one dot name, it knows, it just calls self dot name, which is what we've already passed into name. So it returns John. You can actually name this anything that you want, but you shouldn't do that. You should just do self. Everybody uses self. So just for readability. So that other people that are working on your code base will not have it hard to understand what is happening. So that is that. And we call all of these things attributes, Attributes, name is an attribute, birth year is an attribute. You can think of the same thing as a in the case of a car also. So car dot shape, car dot make, car dot model, car dot color, car dot manufacturing year. Those things are going to be in the attributes because they only tell us something. Those things tell us something about our object. They don't cause our object to do um anything. Right. So I can also, do a lot of other things I can do. Person dot birth here is going to print out the birth here. So returns 2001. Person one dot birth here and stuff like that. Now that is attributes, and we put attributes in the constructor, and our constructor is created using this init method. So we see def under init. Now the next step is to add behaviors, right? You want to add behaviors. We want to make this thing to behave. So a person has some features like name, like their birth year, their nationality, all of those stuff. But another thing that a person has, another side to a person is what they can do. They can sleep, they can wake up when you tap them, they can eat, they can do all of those stuff. So they can breathe and things like that, they can walk. So those ones are functionality. So in the case of a car, things like color, make, model, they are attributes. They go into the constructor. Those are features. Then in the functionality part, you can have, drive, you can have reverse, you can have brake, you can have kick, and things like that. So, and we call those functionality things, we call it methods. Those behaviors, we call it what? Method. So objects should be able to do things. And how do we do that? It's very easy. So let's say a person should be able to um, um, let's say greet other people. So we are going to say def greet, this greet method, and we're going to pass in self. Now, let's say to greet somebody, you need to know the name of that person and just go. It's going to take a parameter name. So if you come here now and just print out f string hi, okay, let's say name of person, set of name, that is name of person that we want to greet. I name person, how are you? Now if I should run this and run this, you're going to see that the difference between a constructor and a method is that methods do not have dunder in it. They don't have dunder in it. And we call this kind of method, we call it instance method. And you're going to understand what that means in a bit. So if I should run that and run this, then come to this place. You still have your person one dot bat here, person two dot, all of that. If I should do person one dot greet, which is a method, and I say name of person to greet is Donald, and it says, "Hi Donald, how are you?" So person two also has the ability to greet. Also, person two dot greet Donald as, "Hi Donald, how are you?" So now it is not just what in this case, you are even going to notice that we are not passing in brackets here because this is not a method. These things are attributes. So whenever you're calling attributes, you don't need to pass in brackets because there is no functionality. There is no need for parameters. Is that right? But in this case, even if the method is not taking a parameter, you still have to pass bracket. This is what I mean. If I should come here and remove this name of person, and it is just self, I told you self is always by default, it's there by default. So it means this particular variable is not taking a parameter. So if I should run this and recreate this, then come here, I don't need to pass name of person here, but I still need to pass in brackets because this is a method to do open bracket and close bracket. So if I should run this, it just says, "Hi, how are you?" Because now there's no parameter anymore. And that is what a method, just a simple example of a method. Now, one thing that I forgot to mention earlier before getting to method about attributes is that there are instance attributes and there are class attributes. And I remember that because there are also instance method, class method, and static method. But let's look at instance attribute and class attribute. That's fairly easy. Now let's say you know a person um what is that trait that every single person all over the world has? Two eyes. Everybody has two eyes. Everybody out there. So I can come here and say inside this class, I can say number of eyes. That is going to be two inside it and not in the constructor. So if I should run this, yeah, and I run this one here, then if I should come to person one, I remove this batch here and just do, I can type it also, but let me just do this. Or maybe control Z. Let me come here, maybe below here and type it so I don't delete that code again. So I'm going to say person one dot number of eyes. That's going to be two. Even though I did not create it here, I didn't create it. I didn't say person one should have two eyes. If I should come underneath and say person two dot number of eyes, that is also going to be two. What is the reason? What is the reason why this is like this? The reason is because if you look at um where is it? If you look at this place, you're going to see that we put it here, and this is called a class attribute, meaning, well, we want every person to have two eyes. We are not saying everybody should be bearing a particular name. Well, you can choose your own name. Name can be different. We are not saying everybody must be given birth to the same year. You can be born anytime. We are not saying everybody has to come from Nigeria. You can come from anywhere. But every single person must have two eyes. So we are not even giving you the opportunity to um pass in, "Oh, this is the number of eyes that I want." No, no, no. Because it is the same across board for everybody. So put that as a class attribute. And upon creation of that instance of the object, you don't have to pass it in because it is not an instance attribute. And another thing is, if there are special cases where just like, okay, this is not right, then you can change it. For example, let's say for some reason person one is special and they have three eyes, and they are just the only person that has three eyes. So we can always come into anywhere and say person one dot number of eyes. Let me show you something first, which is two right now. I can say equals three. Then run that. If I should say person one dot number of eyes, now it is going to be three now moving forward, because we are saying person one has three eyes for some reason. But if you check for person two and every other object, it is still going to be two. Does that make sense? So that is class attribute. So if there is any attribute that I want to be universal, I don't want each instance of my object to have different variants of that particular thing, like name, Betty, and stuff. I want it to be universal. For example, species. I think every human is Homo sapien. So that is going to go into this class person. So that is basically what class attributes mean. So let me add create a class attribute number of eyes that every person must have. Right. That is what happened on this line. But inside here, we are creating attributes that can change from person to person. Perfect. So now let's move on to the next one. And another thing is you can actually change it globally also. I've forgotten that too. But I just remember that rather. So for example, I showed you how to change let's say we want to change number of eyes for only person one. So you can actually change number of eyes globally also. So you can do person dot number of eyes. And if you say that is equals to 4, if you run that, you've globally changed everybody's number of eyes. So if you come and do person 2 dot number of eyes, which was what earlier 2, it is now going to be 4 because we've changed it globally. And the interesting thing is, if you do person 1 dot number of eyes and you run that, you still have 3 because you've specifically turned that particular instance to 3. So that is that. So let's look at the way we've looked at class attributes. The way we've looked at class attributes, let's look at class method. So what's a class method? So a class method is kind of like something that we use to uh, work on the entire class. Whenever we call an instance method, we call this type of method, we call it instance method. So whenever we work on an instance method, that thing is only working on that particular instance of the class. That is, whenever we call dot, for example, let me show you something here. So let's see one more method before we go to class method. So let's say self dot asleep equals true. Now what we are saying is every single person, the moment you are created, that is the moment you are born, let's say upon creation, it is when you are born, you are expected to be asleep, right? So then we are not going to have a method that wakes you up, that wakes a person up. So we're going to say def wake. I'm going to say self. Now, what does that take? So we are going to have an if statement, because if somebody is already awake, you should not be waking them. So I'm going to say if uh self dot asleep, that is, if this self dot asleep is true already, that is, you don't have to say equals true. There's not that's not the Pythonic way of doing things. So just say if self dot asleep, meaning that if self dot asleep is true, then wake them up. So how do we do that? We are going to say self dot asleep equals false. Then we are going to print out f string self dot name is now awake. Then else, that is, that person is already awake, you can print f string self dot name is already awake. Or we can say, oh, you cannot wake somebody that is already awake. So let's run this and run these two guys. And I want you to just pay attention to, let me add two new code cells here. Now, if I should do person one dot asleep. Now, it says true, person one is sleeping. If I should do person, let me print out that one. If I should do print person two dot asleep and run this. That is okay. I should print the one at the top, not actually the second one. But anyhow, let's just do print for both. So person one dot asleep is true. Person two dot asleep is also true because we just created this one. So we are going to wake one of them and leave the other person asleep. So I'm going to say person one dot wake. So if I should run person one dot wake, it say John is now awake. If I should try to rerun it, it's going to say John is already awake. Like, why are you trying to wake someone that is already awake? Now, if we go back to this place and run this, you're going to see that John is person one, and it is not going to be false because John is not asleep anymore. But this is still going to be true because this person is still asleep. So can you see false because John is now awake, but true for person two because root has not we've not done person two dot wake. So root is still asleep. Now that explains what I was trying to say earlier. That is because this wake is an instance method. It is a method that only works on the instance of that particular class. It's not working on the entire class. It's just on the instance of the class. So if we want something that works on the entire class, that is a class method. That is a class method. And let us define a class method. So this grid that you've seen is an instance method. This wake is an instance method. Now a class method. So how do we define that? We're going to say at class method. We use this thing called um decorator. This is a decorator, so we use decorator. Decorator is basically some advanced stuff. It's not really that advanced. It is a function that wraps another function. So, but this not something that we're going to be covering in this scope. But just know that decorators are function that wraps another function. You can look it up. So, and what this decorator class method does, like it's written here, it converts a function to be a class method. So, and this is that a class method receives the class as the first argument. So this is what they mean. So let's say what we want to do is we want to we instead of changing this person's I, instead of changing it by saying person this dot and like that, we want to like just have a method that changes this particular number of eyes. So what we are going to do is we are going to say def change number of eyes. And instead of taking self, instant, and that's like the apart from this at class method, that's like the big difference. So what class method takes is not self, because I told you self refers to the instance. So what it takes is CLS, which is the class itself. So it's a CLS, which is the class. We are giving it the class, and we are going to say new eyes, or let's say no underscore eyes. Let me see. Yeah, or let's call it new number of eyes, right? So the new number of eyes that the person wants to change this variable number of eyes to. So how do we do that? We say CLS dot. Now, the moment we call CLS, it gives us wake, change number of eyes, greet, MRO, number of eyes. I'm just to say number of eyes, which is this one here. That's what we want to change, equals, then we can do new number of eyes. So if we run that and we try to change our number of eyes, for one of the, okay, we need to run this again. So if we try to change that and we say person dot change number of eyes, and we say new number of eyes equals 15. If we run that and we do person one dot number of eyes, what do we have? We have 15. So this method is called the class method. So we now have a method. Instead of doing person one dot this and equals to 15 and stuff like that, we have a method that can actually perform that functionality on every single um, um, instance of the object, every single instance that is created with this particular object. It is going to apply that change. So that is what class method does. So class method works on the entire class. What do you call it? Instance method work on just instance of that particular object, just instance of that particular object. So that is that on the basics of object oriented programming. And there are a lot of like things that we are still going to cover in the part two that you're going to be seeing. There is also static method. Let's just quickly look at static method. What static method? Static method are used like you can think of them as utility functions, right? So something that does not really let's say you are defining a class, and you have something that does not really relate to the object itself. Like it does not really relate. You just need that utility. You just need that thing within the class. Like you just need it. So that is going to be a static method. For example, let's say we need um something that computes, I don't know, age. So maybe something that computes age. You can just do def get underscore age. And you are not actually getting the age of the person. That's not what you are doing. You are just, doing your own, you're just trying to get any age, right? So you can do year underscore birth, comma, current year. And you just go and say return year underscore birth minus, no, that's going to be current year first. I think so. Current year minus year underscore birth. And the way this guy is going to know that this is not supposed to be uh, an instance method or a class method is by saying this is a static method. You wrap it around this decorator. So if we should run this and we call, now if we should call, look at it, person one dot. Now, if you look through this, you have get age, and if you run that and you say 2005 and current year is 2025, and you run that. Now, what happens? It says person has no attribute get age. Yeah. Now, if we should come here and change this to person and run this. Now it worked. The reason why we got the no, now don't forget this person here is the class itself. Again, static method help us to do something, help us to define a function that is not tied to the class or the instance of the class. How is it not tied to the class? There's no self, which is the reason why we had this first error from earlier. Person one is an instance of this particular thing. And if this must work, then you must have self here, right? And because we don't have self, this particular method is only tied to this class, to this class, but not in a way that it uses anything in the class. So it's just a thing that does not touch the instance or touch the class itself. It's static, is something that is different. And it is only used when we want to define something that does not touch any of the data inside the class. So if we do person dot get age and we run that, that is it. So that's why we're going to be stopping for now. And let's take a quick run through everything that we've done. So OOP is a programming paradigm that helps us to model everything, all of our logic, like objects, and it helps us with compactness. We can have code that is compact, that is easily readable, that is reproducible. And whenever we are creating an object, what we just do is we define the blueprint, which is the class. The class is the blueprint that every instance of the object that we are creating will follow. And inside the class, we're going to have the constructor, which takes the attributes of that particular instance of the class. And the other one is methods, which houses the functionality. Methods, models the functionality of the class. And we have different types of methods. Number one is we have the instance method. You define them exactly the way you define your normal function. The only difference is whether it takes an argument or not, whether your method requires an argument or not, you must put self, referring to the instance that you are currently on. Then we have another type of method, which is class method. And class method operates on the entire class itself, not just on a single instance of the class. Then we have static method for defining utility functions and functions that do not, touch the does not touch the instance of the class or the class itself. And yeah, we also have class attributes for attributes or features that are supposed to be universal to every single instance of the class. So that is that. We also saw how to create an instance of each object, and we saw some run through everything. So in the next class, we are going to be looking at the part two of this, which is going to be understanding some core OOP concepts like inheritance, encapsulation, polymorphism, and abstraction. So yeah, that is that. See you in the next one.